We're going to start off this series by jumping right into nomenclature, and we're going to start with some of the basic concepts and a few of the exceptions at the basic level, and then further videos in this series will discuss more complex rules of nomenclature. We're going to start off with an intermediate difficulty, and this molecule has about some of the few fundamental concepts that I'd like to go over. Firstly, what you want to do is number the parent chain. So we're looking for the longest series of carbons in a row, and that's going to be defined as the parent. As you can see, this 5-carbon chain is the longest chain I can get. Now, the next step I like to do is to make a squiggly line as to everything that's not the parent. Oh, I made an error, but I'm going to go back and change that. The number 1 is actually part of the parent, but in this example, it's irrelevant. Anyways, the first thing I'd like to do is write down the name of the parent at the top. So in this example, we have a pentane, and I just kind of keep that there. I do a squiggly line just to represent that everything below is going to be a substituent. And now I go through and just name each substituent separately. Like, I try to associate them with their groups later. So the first thing I do is just realize, okay, at position 2 I have, a methyl. I have another methyl. At position 3 I have a third methyl. And then at position 3 I also have a fluoro group. And at 4 I have another fluoro. And so I just go through and really just in numerical order list down whatever I saw in the example. Afterwards, I just kind of arrange the like groups together just to make it easier, and I then continue to just name the molecule. Now, what you want to make sure of is you want to be alphabetically correct. Numerically, it doesn't matter in this example. So for this example, we'd start with fluoro first because F comes before M in the alphabet. We have 2 fluoro groups, so we actually have to put difluoro. And then we have the 2,2-methyl and then a 3-methyl. So then those are grouped together as a trimethyl. And then I remember looking at the top that my parent is a pentane. Now let's do another example. If we were to start counting from left to right, we actually would get 1, 2, 3, 4, 5, 6, 7 left to right. But this is actually achievable in the other direction as well. So what we have to do here is analyze which way do we actually want to continue our naming and our numbering. If we notice that going from left to right, we encounter the OH group first, and from right to left, we'd encounter the Cl first. The first rule I want you guys to remember is that OH takes priority, because that OH group is actually the part of the parent. This is not a alkane anymore, it's an alcohol. So I go through and I write down the parent name again, and this is heptan 3-ol. I like to put the 3 in the middle of the parent because it kind of signifies where the OH group is. Then I put my squiggly line underneath, and then I put down the substituent 5-chloro. After that, it just comes down to simple arranging the substituent before the parent, and you're done. Now we will do another example. This time we're going to start with the name of the molecule, and then we're going to try to draw what molecule is being represented. What I like to do first is just draw the parent molecule in length, because that's probably the last information you do when you're naming, so it should probably be the first that you do when you're drawing. Just seems to make sense. So I've drawn a 6-carbon molecule, and then now I notice that at the 2 there's an alcohol. So what I'm going to do is go ahead and draw that OH group at 2. Now it just comes down to simple numbering. I have chosen to go left to right. You could have chosen the other way, but I find it easier to go left to right. And I go ahead and draw my 4-ethyl, because that numerically came first, and then I'm going to go ahead and draw my 6-chloro. And there you go. That's all there is to it.